Okay, so what to do next? How do we continue with the results from the ApplanixPPK? For instance, we could use the UASMaster, which provides you a direct handshake to the ApplanixPPK. So first of all, what we could do is checking if the pyramid levels for the images are available to zoom in, zoom out. They are supposed to be there because these are JPEG files, but it's just a counter check. And in case of they are not there for whatever reason, you can simply select the images and then process the image overviews. We then go and open our PRG file, which is the delivery of the ApplanixPPK. And this is a direct handshake between ApplanixPPK and the UASMaster. We then create the camera itself, which we can call from the database. So in that case, we have the DJI camera here, Phantom 4 Pro camera. Put in a name or camera ID. And that comes with sensor size, width, and height information already, and a predefined focal length, pixel size. And if you have PPA information, so principal point of optical emission, you can enter it from, let's say, from a previous calibration or from an existing calibration protocol. If not, you just keep it 0 and you can calibrate it. And here we have an additional vector that we can apply. So your solution is basically referring to the antenna of the GNSS. And we want to bring it now to the camera center, projection center. And in that case, I apply 10 centimeters height offset and horizontally 0. So the antenna is 10 centimeter above the camera. We then load the distortion table or distortion coefficients if they are available from a previous calibration or factory calibration. If you don't have that values, you can certainly calibrate it in this process. We will also refine those values in the current project here. But any initial values that you have are obviously helpful to find better type points in the first round and get the error triangulation converging quickly. So we initialize from our camera, we put in the mean terrain height, which helps also for better type point matching success rate, and import our images here, which get directly georeferenced with GNSS coordinates. We also put the standard deviation for our GNSS centers. So put 3 centimeters, 2 to 3 centimeters is what you can get with a decent base station around. And then we load our ground control points. So if you have ground control points, especially for calibration purposes of your camera, you can simply load them in here. So say what column is east, north, height, and import this. We can then set the standard deviation for the point measurement. I put it around a pixel, which is 2 microns. And the standard deviation of my GCPs, put it about 2 centimeters. And eventually you can also create strip numbers, which is done automatically. So we have 6 strips here, and then we go back to the images and initialize our kappa angle also from the strips. The position is taken from the GNSS centers, and the initial kappa is taken from the strip definition. Same thing here, it helps you for type point matching. So that's it from the setup. We can save this now. And we have a 3D overview. We can see our strips, the image centers, and at the bottom, the ground control points. So we're basically ready to start the georeferencing tool. And the first step here is to create type points. There's some parameters here for type point matching. For now, we take it at weak and medium, which is good enough. If you want to have a higher precision, you can go to high level, creates you more type points on the one-to-one images, and we activate the GNSS centers because we have that available with a very good precision. So run the type point matching, and we can save this now from here and close, go back to the 3D overview. You can see those little dots down there. Those are our type points. You can also see that the image centers have changed a little bit and they're green. So the first arrow triangulation did run already. So we have not only position, but also orientation of the images now. And the next step is we can measure in our ground control points. Ground control points are helping us if we have to do calibration of the camera, but also to get your block georeferenced or basically moved over the ground control points. So you click a ground control point here, measure it in some images manually, and then run the autocorrelation through the other images. So those points are measured in other connected images automatically. There's another example here. I take another point and do the same thing. So I pick it in a couple of images. If it fails for one or the other image, so the correlation fails, you can just pick that image and measure the point manually. So that point has 13 connections. We have 13 images where that point is visible and can be measured. So after that was done, we can run basically the adjustment process, and we can switch on the camera calibration if we want to calibrate the camera. So we determine the principal point of autocollimation, the focal length, and the distortion in that process. So that's done. Obviously, I measured some more points than only two. So we have a list of some more ground control points. And finally, we can print a report. Gives you all the statistics about your adjustment process and about the calibration. So for instance, here we have our camera and the calibrated focal length. We have the PPA, principal point of autocollimation, calibrated, and we have the distortion parameters that were calibrated on the job. Let's search for the sigma value, which is a statistic value, quite important to understand the quality of your adjustment process. So we can see the sigma nu is about 0.8 pixels, so it's less than 1 pixel. That sounds very promising. It's a good result. And down here, we can also see the RMS of the GNSS centers, which are below 2 centimeters. We assume 3 centimeters at the beginning, but 2 is what is estimated, so it makes sense. And then we also can check our RMS values at the ground control points, which is around 1 centimeter in that example. So let's close the report from here. We go back. So we have done the calibration. We have done the adjustment already. Just pointing you again to the camera here, you can see there's a new camera file that was created. Focal length, PPA was calibrated, as well as distortion. And the camera can now be used also for future projects with the same values, unless you want to recalibrate on the job. But you can always use them as an initial value for other projects going forward. So the next steps here will be radiometric optimization if you need to do, and then you can do DTM matching, DSM matching, and orthophoto generation, mosaicing, which is not part of that video. So thank you very much for your attention. And again, try ApplanixPPK.